Hello, welcome to your tutor. And in this video, we're going to be looking at energy, specifically kinetic energy and potential energy. So we've got, I'm sure we understand kinetic energy. This is basically energy in motion given by the formula Ke representing kinetic energy. But in physics, Ke can present another value, but I'm just trying to make everything simpler. So kinetic energy is equals to half mass and then velocity squared. So this is a general equation of kinetic, or the formula for kinetic energy. Others would express this as mass velocity squared over 2, but it's basically the same thing. Yeah, so this is our general form for kinetic energy. And then we also have another form of energy which I talked about earlier, potential energy. So potential energy is the energy that a body, especially a stationary body, possesses due to it being at rest. Yeah, so basically uh potential energy is mass multiplied by gravity multiplied by the height of the object above a certain point. So if you look at the potential energy formula, you see that we've got an aspect of height. So what does this height imply, or what does it entail us? So let's say we've got, let me just draw, let me just make a quick illustration. Let's say we've got a box. Let me just edit that. Yeah, let's say we've got this box. Let me just shift it here and let me make it taller, but let me not make it interfere. Yeah, so let's say we've got this box. So one thing that we need to understand is that every time given something directly like this, notice that there's a direct proportionality to this thing. So implying that potential energy is directly proportional to the mass and the gravity and the height. But notice that mass in physics is always something that's constant. It's always something that's constant. It doesn't change. It is constant, represented by K. And also gravity is constant. We know that the value of G is 10 newtons or 10 meters per second squared. It depends with however you want to express it. But notice that height is delta s, or the change in displacement or distance, as others might put it, is a changing value. So implying that potential energy is directly proportional to the height. Now I'm going to explain what this means in a second, but this implies, well, let me just bring that back, redo. So this implies that, let's say you this is a 500 meters, let's say this is a 500-meter box. I know that can't exist, but yeah, okay, let's say we've got a box of 500 meters, implying that at the top here, let's have our potential energy, our PE. So here, notice that since we are at the top of the cliff, the height is greater. So implying that the potential energy will be at its maximum value. So here we have the maximum of potential energy. So this, our potential energy will be max. And then notice that since we are at the top of the cliff and we do not have anything in relation with velocity squared and mass, so implying that once we are here on top, our kinetic energy, our Ke will be at its minimum value, yeah. So now let's say we were at 250 meters. Let's say this was our 250 meters of the cliff. Let's say we're at 250 meters. So once you're halfway of the box, there's an interesting phenomenon that happens at this point per se. Because let's say we had the ball here, and then let's say we had the ball, and then the ball was falling. So once the ball reaches halfway, which is at 250 meters, its potential energy, becomes equal to its kinetic energy. So this can draw up a conclusion that at 250 meters, let me just show that here, at 250 meters, our potential energy is equal to our kinetic energy. So our mass and gravity and height become equal to our mass and our velocity squared over 2. These two things become equal. So you might see a formula like this appearing in your physics books or physics textbook, but you don't have to really get lost. It just means that at a certain point, our kinetic energy and our potential energy became equal. Now, what happens when we go at the bottom? So once we reach the bottom, the complete opposite happens. At the bottom, our kinetic energy, our Ke, reaches its maximum value. So our kinetic energy is at its maximum value. And then once our kinetic energy is at its maximum value, then our potential energy, our PE, reaches its minimum value. This is just at the bottom. So we need to understand the energy changes that take place. Potential to kinetic, potential and kinetic become equal once halfway of a certain top. Yeah, so we just have to understand those energy changes. And then these energy changes may also be asked in terms of a ball. Let's say we had a straight line here. Let's say we had a line, and then let's say we had a horizontal surface. Let's say we had, yeah, let's say we had this, and then let's say we also had a ball bouncing. So let's say this was our ball bouncing. So let's say this was our ball, and then the ball was bouncing from here to the top, and from the top back down. So what you need to understand is that the ball will also undergo the same changes. So here our potential energy will be at its max point. Our potential energy will be at its maximum point, and then here our potential energy will be at its minimum point. So those are just a few things that I wanted to highlight in terms of kinetic energy and potential energy. So if you've enjoyed the video, please subscribe, and I'll be seeing you guys in the next one. Thank you very much.